All right, Mr. Ahmed here, working on 10.6 today. Essential question is how do we find segment relationships inside of circles? So in 10.5, we went over a whole bunch of cases to find angles and arcs. We had chords, we had secants, we had tangents. The same looking diagrams are now going to apply, except we are going to find the lengths of segments. So the first one is two chords. I call this the parts of the chord. So what we have to do is we have to take each chord, A to B, that's two parts. So I'd take part A times part B, so part times the part is equal to the other chord's part times its part. So that's C times D, part times part. It's kind of in words. So we have to look at each separate chord. Our first one's going up and down, so we take C times D, and the other one is A times B. Those products are equal to one another. All right, so that's how we set up our formulas. So looking at our first example for the parts of the chord. In example 1, we are supposed to find X. So I'm going to look at the first chord, K, M. Order's not important. So I'm going to take K, M. So that's part times part, 3 times 8. Use a dot. Equals the other chord's part, 2 times its other part, which is 3x. And that is how we'd set up the equation to solve for x. Each separate chord. So I'm going to highlight the first one. Its first part was 3, second part was 8. 3 times 8. Second one was 2 times 3x. So 24 is equal to 6x. Divide x is equal to 4. Okay, next one. Same process, parts of the chords inside. So I'm going to look at the first one, x to y, so that's 4 times 9, and equal to the other one, x times x. Keep in mind, x times x is not 2x. X times x is x squared, equals 36. Take the square root of both sides. Has to be both the plus and the minus because I inserted it, so x is equal to plus and minus 6. Now the question here is, can I have a negative length? No. So it's just the positive solution, which is x is equal to 6. Next rule involves us looking at two secant segments, okay? Now this one, again, I break it into part. So when I set it up, I look at each segment. The first segment is A to C. I take the outer part times the whole thing. So that's AB. So outer times the whole is equal to the other segment's outer part, AD, times the whole. Now when you get the whole thing, you have to add up the two parts, okay? So first example, finding x. Doesn't matter the order of the segments. I'm going to take the one on the top first, Q to R. So the outer part of QR is 3 times its whole thing. Its whole thing is 3 plus 10, which is 13. I got that by taking 3 plus 10, the whole segment. Now the other one, outer part, outer, 2 times the whole thing, 2 plus x. Okay? Now we'll solve. 3 times 13 is 39. Distribute 4 plus 2x. When I subtract, 35 is equal to 2x, and x is 17.5. Okay, so the hardest part's setting them up. Next one, two secants. Outer times the whole. Outer 7 times the whole thing, 7 plus 19, 26. Added the two parts together, equals outer part, 8, times the whole thing, 8 plus x. Now when I solve, 7 times 26 is 182 equals 64 plus 8x. Subtract, 118 equals 8x. And x is 14.75. Okay, so outer times the whole equals outer times the whole. That's with our two secants. Next formula involves a tangent and a secant. In this case, when I set up the equation to find the segment lengths, the tangent length squared is equal to the outer times the whole again. Make sure when you get the whole, you add the two parts, okay? AC is the outer, the whole thing is AD. So, first example. Tangent squared, the tangent is 6. So 6 squared equals 2 times the whole thing. Now the whole thing in this case is 2 plus x plus 6. Combine the like terms. Okay, combine those like terms. And we get x plus 8. Okay, I just want to backtrack here real quick. I wasn't sure if I showed my formula real well. The tangent squared is equal to the outer, AC, times the whole, A to D. Okay? I wasn't sure if I had that on the screen. So, backtracking to finishing up our problem. Tangent, 6 squared, the tangent segment squared, is equal to the outer part 2 times the whole thing, combined the like terms. All right, next step, when I square it, 36 equals 2x plus 2 times 8 is 16, have to distribute. Subtract, 20 equals 2x, and x is equal to 10. All right, last example. Again, the tangent is x. So the tangent squared equals the outer part, 8, times the whole thing. Keep in mind the whole thing is 8 plus 10, which is 18. All right, when we solve, 8 times 18 is 144. So x squared equals 144. To undo the squared, take the square root. X is equal to both the positive and the negative, plus and minus 12. However, can't have a negative length, so it's just the positive value of 12. And that is it for 10.6.